Welcome to this explainer. Have you ever actually paused to just wonder what the chair you're sitting on right now, or the water you're drinking, or even the air you're breathing is actually made of? Well, today we're going to zoom way in on the everyday objects around us to uncover the hidden chemical building blocks that make up, well, literally our entire universe. We're going to play detective and figure out the true nature of matter.
So here's our roadmap for today. We're going to cover the makeup of everything, the world of mixtures, elements as the building blocks, chemical combinations called compounds, a little showdown between mixtures versus compounds, and finally, matter in our world.
All right, part one, the makeup of everything.
Okay, so consider a bowl of poha, or, a really vibrant garden salad. They look incredibly colorful, and every single bite tastes slightly different. But what fundamental, scientific property do these everyday meals actually share?
The answer? They're both mixtures. This just means their ingredients, like the tomatoes, the onions, maybe some chickpeas in your salad, are physically combined. And because they're only physically mixed, each ingredient totally keeps its own individual properties, its own taste, its own color. Plus, you can easily just pick them apart by hand if you want.
Moving on to Section 2, the world of mixtures. So, in science, mixtures are basically categorized into two main types. First up, we've got uniform or homogeneous mixtures. This is where components blend so seamlessly together that you literally can't tell them apart. Think oxygen dissolved in water or aerated soda water. On the flip side, we have non-uniform or heterogeneous mixtures where the pieces remain visibly separate, kind of like grabbing a handful of sand mixed with pebbles. You can clearly see all the distinct parts.
Now, in daily life, we might call unadulterated milk pure because, well, it's clean and it hasn't been mixed with any cheap fillers. But chemically speaking, milk is actually a mixture. It's a really complex blend of water, fats, proteins, and minerals. And honestly, this realization naturally leads us to seek out what a true scientific pure substance actually is.
Which brings us to part 3, elements, the ultimate building blocks.
Let's actually run a classic experiment to see if we can find something truly unbreakable. We'll take water, which we usually just think of as a single uniform thing, and we're going to pass a really strong electric current right through it. If water is a mixture or a compound, this intense energy might just force it to split apart physically or chemically. We'll collect the gas bubbles that form in two separate test tubes, and then test those invisible gases with a burning candle.
And wow, look at the result. The electricity literally rips the water apart into two completely different pure substances. One gas makes this distinct pop sound when the candle gets near it, that's hydrogen. The other gas makes the candle flame suddenly glow way brighter, and that's oxygen. We literally just tore water apart into its foundational building blocks.
These fundamental, absolutely unbreakable substances, like that hydrogen and oxygen we just saw, are called elements. An element is a pure substance made of only one single kind of atom. Scientists have discovered 118 known elements in our universe, and they neatly classify them into three main buckets: metals, nonmetals, and metalloids, which kind of sit right in the middle with properties of both.
You can see this stark contrast perfectly right here. On one side, we have a shiny, highly conductive metal, like silver, and on the other, we see a dull, brittle nonmetal, like carbon charcoal. These are the pure elemental ingredients of the universe, and as you can tell, they look and behave in vastly different ways.
All right, Section 4, compounds or chemical combinations.
Let's put our detective hats back on. This time, we're going to take some common table sugar and gently heat it in a boiling tube over a burner. Now, we aren't just mixing things anymore. We're using heat to actually force a chemical reaction. As we watch, the sugar melts, it turns brown, and then it does something incredible.
The heat breaks the sugar down completely. It leaves behind this black coal-like residue of pure carbon. And if you look really closely at the glass, tiny water droplets are forming. This proves, absolutely beyond a shadow of a doubt, that sugar isn't an element. It's actually a compound. It's a completely new substance made of chemically bonded elements, carbon, hydrogen, and oxygen, all locked tightly together.
This leads us to Section 5, mixtures versus compounds.
Let's set up a little showdown. Look at sample A. Here, we're physically mixing dark iron filings and yellow sulfur powder together on a dish. Now, because this is just a mixture, meaning they aren't chemically bonded at all, each element totally remembers its own rules. If you hover a magnet right over this dish, the iron is immediately attracted to it. You can literally pull the iron right out, leaving the yellow sulfur sitting right there. But if we take that exact same mixture and hit it with some intense heat over a burner, we force those elements to chemically bond. They fuse to create sample B, iron sulfide. Now, this is a completely new substance. If you hover that exact same magnet over sample B, nothing happens. No reaction at all. The new compound completely ignores the magnet because it's taken on entirely new properties.
And this data totally proves our case. Mixtures basically retain their original separate rules. Like, the iron is still magnetic, and if reacted with acid, the hydrogen gas still burns with that signature pop. But the compound, sample B, it forges entirely new chemical identities. It's no longer magnetic, and its chemical reaction produces a gas that smells strongly like rotten eggs. It's a massive, fundamental transformation.
Finally, Section 6, Matter in Our World.
Just look at these breathtaking minerals found deep within the Earth. Things like the beautiful crystals of quartz or the flaky layers of mica. These are naturally occurring compounds, formed when two or more elements lock together chemically over millions and millions of years deep underground.
And, of course, we humans have harnessed this power too. By deeply understanding whether matter is a simple mixture that we can easily separate or a really tough compound that we have to break apart chemically, scientists can literally invent the future. I mean, we mix metals into alloys to build stronger bridges, we synthesize complex chemical compounds into life-saving medicines, and we engineer new elements into the tiny batteries that power our smartphones every single day.
There's a quote that really hits the nail on the head here. Elements and compounds are the basic building blocks of matter. By understanding what matter is and what it is not, we can better explore the materials and phenomena that make up our universe. Grasping these fundamental differences, knowing how atoms mix, bond, and react, is literally the master key to unlocking the secrets of our entire universe, from the soil right beneath our feet to the farthest stars in the sky.
So, now that you understand the hidden rules governing all matter, I want to leave you with this final thought. If you had access to the universe's ultimate toolkit, the 1118 pure elements, and you could arrange them to invent a brand new, never-before-seen compound, what kind of world-changing problem would you choose to solve? Thanks so much for exploring the building blocks of reality with me in this explainer. Keep questioning what makes up the world around you,